Hello everyone, welcome to the channel Top Gate. In this video, we'll study a new concept, that is the conversion of NFA to DFA. In the previous lectures, we have seen what is a DFA, we have seen what is the NFA, we have seen the designing of DFA, we have seen the designing of NFA also. In this one, we'll focus on the conversion of NFA to DFA. Now, there are certain situations where it is very difficult for us to make a DFA for a particular problem. So for that purpose, just for the simplicity's sake, we make NFA first and then we convert the NFA to an equivalent DFA. Now, why do we convert the NFA to DFA? That is just because the DFA is a complete system in itself. The power of NFA and DFA both are same, but DFA is a complete system in itself. Therefore, we make the NFA for a particular problem and then we convert it to a equivalent DFA. Clear? So if you make a NFA for a problem and you don't know the conversion of NFA to DFA, then making of this NFA becomes useless for you. Clear? So you need to learn the conversion of NFA to DFA. That will focus in this particular video. Now, if you see in this one, here we have this NFA and this NFA needs to be converted to a equivalent DFA. Now, there are many students who are confused in finding out whether this machine is a NFA or a DFA. So how to find out? If you see this one, you can see that here in this particular finite automata, we have two kinds of inputs. One is A, one is B. So for a DFA, it says if we have two inputs, then every state must have exactly two outgoing paths, one for A, one for B. But that is not the case for this NFA. In NFA, I can have several paths for A, I can have several paths for B also. So if you talk about Q0 here, you can see from Q0, I have not two, but three outgoing paths. One for A, again one more for A and one for B. So I have two paths for A. Now this case is not there in a DFA. In DFA, every state must have exactly one path for every input alphabet. So here this Q0 is not satisfying the property of the DFA, therefore this machine is not a DFA, it's a NFA, and therefore we need to convert this NFA to the equivalent DFA. Now, conversion of NFA to a DFA is quite a simple task. You just need to follow the simple steps and we can just simply make a DFA. Now, straight away we'll make the table for the equivalent DFA. So let's make the table for the DFA. So I'll just write state here and then A and then B. So I'll make a table. Okay. Now what we do, whenever we make the table for the DFA from the NFA table, this is the NFA table and this is the equivalent DFA table. So what we do, the first step that we have is we just have to copy the very first row into the DFA table. Okay, so we'll just copy the first row. So in the first row I have this Q0, that is your initial state, and then here Q0 and Q1. Now this in NFA table you can see from Q0 with A you can move on to Q0 and Q1. But this cannot be there into a DFA. So what we do, we just combine both of these states and then we write Q0 Q1 in these brackets. So this means that Q0 Q1 in a DFA is a single state. Here in the NFA it was two states, that is I have Q0 and Q1 both are independent. Here I have combined Q0 and Q1 together. Clear? Next thing is Q2, I'll simply write Q2 now. Clear? Now how to complete this table? What I'll do, I'll just divide this table into two halves. This half is called as the LHS and this half is called as the RHS. Clear? Now what I have, anything appearing on the right hand side, any state appearing on the right hand side, either this column or this column, has to appear onto the left hand side. Clear? So I'll follow this principle. Anything appearing on the right hand side should appear onto the left hand side. So on the right hand side you can see I have Q0 Q1 and Q2, that is not here in the left hand side. So first thing is Q0 Q1, so therefore I'll copy Q0 Q1 here. Clear? Now I'll take this Q0 Q1 here and I'll come here and see with Q0 Q1 where I'm transiting with A and B. So for Q0 Q1 I have, you can see here Q0 Q1, I have Q0 Q1 Q0. So I'll not repeat it, so I'll simply write Q0 and Q1 again in brackets. Clear? Now for B, Q0, Q1, B, I have Q1, Q2. So I'll simply write Q1, Q2. Clear? Again, I'll follow the same principle. That is, anything appearing on the right hand side should appear on the left hand side. So Q0, Q1, it's here. Q2 is not here. So next I'll write Q2. Now for Q2, I'll go to the main table. For Q2 with A, I'm not having anything. This is there, possible in NFA, but it is not possible in a DFA. Clear? So in DFA, I should have something, but here I have a dash here. So I'll simply write phi here. This phi is called as a dead state. That means if I move on to this dead state, there will be no way so that I can go back to the final state again. Clear? So for Q2, I'm having phi, and for B, I'm having Q0, Q1. So I'll simply write Q0, Q1 in brackets. That is, here Q0, Q1 is a single state. Again, I'll follow the same principle. Q0, Q1, it's here. Q2, it's here. Next, Q0, Q1, it's here. Q1, Q2. I'll copy Q1, Q2 now. Now Q1, Q2, I'll go to the main table, NFA table, and I'll see for Q1, Q2. For Q1, Q2 with A, I'm having Q0. So I'll write simply Q0 here. And for B, I'll write Q0, Q1. Q0, Q1. Clear? Again, see, anything appearing on the right hand side should also appear onto the left hand side. Q0, Q1, it's here. Q2, it's here. Q0, Q1 is here. Q1, Q2, it's here. Q0, Q1, it's here. Q0, Q1, it's here. Q0, it's here. Only phi is not here. So I'll simply copy phi here, and with phi, you can see there is no phi here. So I'll simply write phi here and phi here. Okay, now this is the final DFA table, and therefore now with this DFA transition table, I can make the transition diagram for this particular DFA. Clear? So in this one, I have 1, 2, 3, 4, 5 states. So I'll draw all those 5 states. Q0, and then I have Q0, Q1, and then I have Q2, then I have Q1, Q2, and then I have phi. This 5 states we have here. Okay, Q0 is the initial state, so I'll mark it as initial. Now see, from Q0 with A, I'm moving on to Q0, Q1. So with A, Q0, Q1. With B, Q2. So with B, I'll move on to Q2. Come to Q0, Q1. Q0, Q1 with A, Q0, Q1. That means it is a self loop. Q0, Q1 with B, it is Q1, Q2. That is, I'll move on to Q1, Q2 with B. Come to Q0, Q2. For Q2 with A, it is phi. Phi. Q2 with B, it is Q0, Q1. Is B. Come to Q1, Q2. Q1, Q2 with A, Q0. With A. Q1, Q2 with B, it is Q0, Q1. B. And come to phi. Phi I have with A and B, it is phi only, that is A, comma B. Clear? Now deciding the final state, which one will be the final state? So in the NFA, Q2 was the final state. So in the DFA, wherever I'm getting Q2, that becomes my final state. So you can see here I have this Q2 here, so this becomes my final state. I have Q2 here also, that also becomes my final state. So in the equivalent DFA, I have 2 final states. So I'll just simply mark it. So Q2 becomes my final state, and Q1, Q2 also becomes my final state. So this is the equivalent DFA to this particular NFA. And you can see here that this phi is acting as a dead state, and dead state is a state with where I have no means to go back to any of the final states. Clear? So if you see this one, this Q0 will have only 2 outgoing paths, one for A, one for B. Q0, Q1, 2 outgoing paths, one for A, one for B. Q1, Q2, 2 paths, one for A, one for B. Q2, 2 paths, one for A, one for B. Phi, 2 paths, one for A, one for B. So this is your DFA for this NFA. Thank you so much.